How's it going, everyone? In the last video, we introduced the concept of float and how it is related to the critical path. In this video, we are going to take that concept much further and dive into exactly how float is derived. This video is going to be a little different than the others in this series. It is going to be a little longer, and we are going to go into much greater level of detail. The reason we are paying such special attention to this topic is because the concept of float is a foundational idea when it comes to project management and schedule analysis. While I do believe you could skip past this video if you're just looking for a basic understanding of critical path analysis, if you are looking to take your skills to the next level, having this level of understanding is crucial. This understanding is especially important when troubleshooting, as you will understand the why behind much of what is happening in the schedule, which will allow you to better fix your own problems as they arise. To start this off, I want to introduce a few terms that are important. I'm not usually one to use PowerPoint. They're usually painfully boring, so please bear with me through a few slides. So to start, I want to introduce a few terms that are important. From here, I will then jump into a real example in MSProject to reinforce some of these concepts. So here you can see a very basic series of tasks. Each task is 10 days, and they start one after the other. The first idea I want to introduce is a forward pass. The idea is that we run through the network left to right, start to finish as time is progressing. We start here at the start of task A, we go through task A, onto task B, onto task C. The start is earlier than the finish, we progress left to right. If my mini schedule here started on 1/1, that's my project start date, and the first task here is 10 days, we know that it would have a start date of 1/1 and an end date of 1/9. You might think it's a little strange that the end date here is 1/9 and not 1/10. 1/1 plus 10 days duration is 1/10. So let me explain this. The first task officially starts 1/1 at 8 a.m. and finishes at 5 p.m. or whatever you have determined the duration for a work day. So if my task duration was 1 day total, it would have a start and finish date of 1/1. If you added the little timestamp to your date, it would say 1/1 8 a.m. start and a finish of 1/1 5 p.m. An easy way to remember this idea is when trying to find the end date of a task, take the start date, add the duration, then -1. That simple. So if I continue to step through this path, I will get these dates. 1/9 to 1/10 starts 1/10 at 8 a.m., goes to 1/20 -1, 1/19. Next start date is 1/20, 8 a.m., up to 1/30 -1, 1/29. These dates are referred to as the early dates, meaning they are the earliest that these dates can occur based on our schedule. So now that we've gone left to right, we now need to go back right to left. As you might have guessed, this is called a backwards pass. This works in exactly the same way as the forward pass, except we go from right to left, later to earlier. We go back in time. These dates in red are referred to as the late dates, i.e. the latest that these tasks can start or finish. One quick note to mention before I move on. Late dates are always calculated from the deadline date we may have. And if we do not have a deadline date, they just start from the finish date of our last task. So in this example, we haven't called out a deadline date, so our late date calculations just starts from the latest of our latest task. So that would be 1/29. So we find our early dates left to right, wraps around, starts 1/29, goes backwards. It goes -10 days to 1/19, +1, we're going the other way now, to 1/20. Step back 1 day, 1/19, -10, 1/9, +1, 1/10, and so on. This idea might not be totally clear yet, but bear with me. We'll go into a few more examples and it should become more clear. We have early dates now and we have late dates, but why do they matter? Bringing these two together, we get to this key calculation. Late dates minus early dates equal float. In practice, we can take any late finish or late start and compare it to its corresponding early start or finish, and we can find our float. So what is the float on this path? Let's take any of the late dates, say 129, of this last task here. If I subtract the early finish of that task, 129, I get the float value of 0 days. If I compare any of the dates on this path, the answer will be the same, 0 days of float. And we can see that, 119, 119, 110, 110, 19, 19, 11, 11. So let's look at another example. So this example is the same as the prior example in that we have the same 3 tasks, A, B, and C, all 10 days. However, we now have a deadline date of 131. This means I have to complete these 3 tasks by my deadline of 131. We know from the forward pass that the earliest we can finish these tasks is 129. We found that in the last example. To perform our backwards pass, we always start at our constraint date, as I mentioned before. We start here at 131, our constraint, and work backwards. Using the same process as before, we get to our earliest late start, which is 1-3. Hopefully now this clarifies the point I made about the backwards pass earlier, as it should always start at our deadline date, as we did here, 131. If in this example there was no constraint date, we would start right at the last date for our task C here, wrap around, start at 129, and we'd end up with 0 days slack again. We will see in later videos that in any schedule that does not have any deadlines, the critical path will always have 0 days of float, exactly for this reason. The backwards pass will always start at the end of the latest task, so the early and late dates will always match on the longest path in an unconstrained schedule. So wrapping up our example here, what is our float value? Using our late finish on task C here, we can subtract the early finish of task C to find our float value of plus 2 days. 131 minus 129, 2 days difference. So our total float value is plus 2 days. This means we have 2 days of margin on this path. This is a good time to mention, if anyone ever asks you, what's the latest I can start a certain task, you will know immediately, you just check your late dates. Towards the end of this video, I will show where this can be found in MSProject. Moving on to a slightly more complex example, you can see we have path A, B, C here at the top, and below we have path D, E, C. Starting with the forward pass, we get these dates. Notice the early start for task C. It is being held at 118 by this top path of A, B, finishing up 117. So this is the earliest task C can start. Notice the gap here between 113 and 118. We'll come back to that. If we then run a backwards pass along this top path, we get these dates. There is no constraint on this example, so we know they're going to be the same, and they are. We also know now then that this is our critical path and the float is 0 days. But what about the bottom path? How do the late dates shake out from the backwards pass for the bottom path? We can see from these late dates that this path will not have 0 days. The late and early dates do not match. We start to notice a difference here on task E. The latest it can finish is 117 because the latest task C could start is 118. Doing some quick math on any of the early or late dates, we get 4 days of total float. So the top path has 0 days float, and the second path has 4 days of total float. One last concept to mention is the idea of free float. Every task in our schedule will have a total float value, which we've just found for all these tasks, and a free float value. The definition of free float is the amount of margin between a task and its nearest direct successor. So let's look at task E. Its early finish is 113, and the early start of its nearest successor is 118. So we know it has some free float. So what about task D? We can see that task E starts immediately after it, 19 to 110. So we know that task D has 0 days of free float. It has no margin to move. So to summarize this bottom path, task D has 4 days of total float, as we found before, but 0 days of free float. Task E also has 4 days of total float and 4 days of free float. Free float is useful when determining if a task can start later than is currently scheduled without having to impact any tasks downstream. I know I can push task E out to the right at least 4 days before it impacts any other task downstream, because the only task in this example is task C, and we know that's currently being pushed to 118. So now that we have a good handle on the fundamental principles of float, let's go back to our Microsoft project example and see how these ideas are reflected in project. So back at our Microsoft project example, you can see that I've added some columns. It's a little bit crowded, you can't see the Gantt chart as well, but I've added these columns to represent some of the things we've been talking about so far. Since this schedule doesn't have any deadlines assigned, it makes sense that the critical path, highlighted in red here, has 0 days of total float. The start and finish columns represent the early start and early finish. You'll also notice there is an explicit early start, early finish column. So let me explain these two sets of columns. The early start, early finish represents the explicit earliest start and earliest finish of each task, just like we described before. These are pulled directly from our forward pass. The start and finish columns represent the actual dates that that task is going to start or finish. Now, in practice, the start and finish columns almost always match the early start, early finish columns, because by default, each task has a as soon as possible constraint type on it. If I come in and double click on a task, go to the Advanced tab, you can see this constraint type. This just says the task will start as soon as the schedule determines it can, as soon as all of its predecessors are complete. There are other options you can use, so as late as possible. So if I change this to as late as possible, hit OK, you can see the early start, early finish haven't changed. That's still the earliest it could start and the earliest it could finish. But now the task is actually starting as late as it possibly could, and it's finishing as late as it possibly could. So now the start and finish date match the late start, late finish. As a scheduling best practice, all tasks should be scheduled as soon as possible by default. There are some uses for as late as possible, but we're not going to cover those in this video. So I'm just going to change this back. Double click, Advanced, as soon as possible. Okay. So as I mentioned, you can see the late start, late finish. Those represent the latest a task can start and the latest a task can finish. If we go through some quick math, comparing the early and late dates, you'll see that they match the Slack values. Be careful, we're talking work days in project now, not just calendar days, so the dates might not match perfectly with the math. But looking at our 0 days column, we can see early start, early finish. They're all as soon as possible, so the start finish date are the early dates. They match 1 for 1 the late dates, so our Slack value is 0 days. Lastly, let's check the free float values. You can see that the last task in each of the sets of tasks has a lot of free slack, and if we just visually look at the Gantt chart, that makes sense. The only successor for make reservation for the music is the project milestone, and there's a big gap here, so we know that we have some free slack, as it's shown here. We can also see that there's no free slack on the critical path, as there's no room between tasks for anything to move. But what would happen if I shortened design invitations? You can see it feeds in on a separate path to the top two. So let's see. If I make it 3 days, you can see now I've got 3 days of free Slack. This can move out to the right 3 days without impacting its successor, prepare and send out invitations. This makes sense as you can clearly see now discuss potential guests, whittle down list are driving that task and they remain red. So this has been an in-depth look at the fundamentals of Float. I hope this has been helpful and I'll see you next time.